You can take some robots, take some smart people and engineers and make something really nice and work quickly and efficiently, especially in the multi-robot space. The problem is that doesn't generalize well. Suppose you got two robots that coordinate very well and do this whole thing very nicely. Maybe add another robot, the whole plan will break. And this work tries to pose the problem in a more general framework that, given what we call macro actions, you could use the planner that we have to go out and solve a problem. So this was an instance of a multi-agent planning problem that involved a Pier 2 robot, and then we also had two turtle bots, and there are waiters. The turtle bots cannot communicate with one another unless they are nearby, and the turtle bots don't know if someone's going to want to place an order when they go to the room or not. The turtle bots also don't know what the other turtle bot's doing. One way you can try to reduce the problem is using what are called macro actions. And the macro actions, they can be described in a general way of just like what their effects are. And so when you do that, you can cover up a lot of details in trying to coordinate the behavior between the robots. You would like to just say, okay, that one go to room 1 and that one get a drink. You don't want to actually be thinking about the navigation problem. The turtle bots started out in a location and they immediately looked at what they should do from there, like what's the macro action. So it would go inside a room and ask, like, do you want to order a drink?
Do you want to order a drink?
The student had to say yes by toggling the button. If they didn't, the turtle bot assumed they did not want to drink. So the observation it would get inside a room would be, I'm in this room and there's a drink order or there's not a drink order. If the turtle bot went to the Pier 2 and got a drink, its new observation would be that it's holding a drink. If both of the robots were in the bar, that's when they had that limited communication where they could detect if one of the turtle bots was being served by the Pier 2. And so if that was the case, they would go and do a different macro action. There's two phases in this process. The first part is offline. And in the offline process, you are thinking about all of these problems of how are you going to get the robots to coordinate their actions, given that you know they won't be able to communicate all the time, given that you know they won't have knowledge about the whole world where other robots are. So when you're creating a plan for each of the robots to be running individually, that's when you reason about all these things. And then when you're actually executing these controllers, you don't think about any of those sort of things.